How can we tackle oceanic waste? Introducing Solclean. Solclean is a clean and cost-effective solution that uses sunlight to remove pollution in seas. A Peltier chip is used to convert the sun's heat energy into electricity that powers an automated garbage collector placed in the sea. But how did we come up with this idea? Our inspiration came from solar cookers that use the reflection of sunlight to cook food. By incorporating similar reflectors into our design, we are able to heat up one side of the Peltier chip without consuming any fossil fuels. Because seawater has a high heat capacity and is found naturally in abundance, we decided to float our Peltier chips on the sea so that the cool side of our Peltier chip can remain sufficiently chilled. Given the choice of our hot and cold thermal reservoirs, we decided to incorporate our design as a localized power generating unit in marine applications. One project that we have chosen to modify was the Sea Bin project, which uses a water pump to automatically collect garbage floating in the sea. Currently, sea bins can only be used in coastal areas where electricity is available to power the water pumps. However, our modification can allow sea bins to be deployed further away from the coasts. Furthermore, fossil fuels are no longer needed to be consumed to power the sea bins as our modification uses sunlight instead. So let's take a look at how Solclean works. Solclean is a floating device that harnesses heat from the sun to create a temperature gradient between the solar oven, which is the hot reservoir, and the ocean water, which is the cold reservoir. This generates a current that powers a motor that drives water through the sea bin. This water slowly drags floating rubbish into the sea bin. Solclean is made up of multiple layers of insulation so as to maximize the amount of heat trapped. The hot reservoir consists of a metal mug filled with water, which is heated up by the sun, while the cold reservoir consists of a heat sink submerged in ocean water, allowing heat to be carried away by convection through the seawater. By painting the metal mug black, the amount of radiation absorbed is increased. The mug is also filled with water which has a high heat capacity, thereby allowing water to retain the higher temperature for longer periods of time. Finally, the mug is covered so as to prevent heat loss through convection. To prove the feasibility of our system, we approximated the heat gain from the sun by the solar oven and calculated the heat loss to the surroundings. By doing so, we can then calculate the amount of useful heat that can be converted to work done by the water pump and the efficiency of Solclean. So how efficient is our system? We first calculated the thermal resistance and heat transfer out of our system. Then using the solar radiance plot to approximate the heat gain from the sun, we can then estimate the amount of useful heat that can be converted to work done by the water pump and the expected efficiency of Solclean, which is about 1.83%. Some things we can do to improve the system. We can install bigger and better reflectors like mirrors, improve insulation by using thicker upper glass to trap more heat, use materials that can absorb radiation better, increase the area that can collect the sunlight, connect more Peltier chips to the system, or increase the size of the cooling fins.